In 1943, a Harvard psychologist walked into the offices of the National Defense Research Committee with one of the strangest proposals the U.S. military had ever received. B.F. Skinner, already famous for his work on behavioral conditioning, suggested that America's guided missile problem could be solved by pigeons, not carrier pigeons delivering messages, but pigeons physically installed inside missile nose cones, pecking at screens to steer weapons toward their targets. The committee members listened in stunned silence. Skinner explained that pigeons could be trained to recognize targets, that their reactions were faster than any mechanical system, and that they worked without electricity, immune to jamming or malfunction. He had built prototypes. He had trained birds. The system worked. The committee thanked him politely and rejected the proposal. It was too absurd, too unconventional, too much like something from a cartoon. The idea of America's military power depending on birds seemed laughable, but Skinner wasn't joking. His pigeons could guide missiles more accurately than any technology of the era. The military just couldn't accept that organic computing might outperform mechanical systems. Burris Frederick Skinner was born in 1904 in rural Pennsylvania, the son of a lawyer. He was a curious, inventive child who built elaborate contraptions, from a flotation system to separate ripe elderberries to a door-closing device activated by a rope. At Hamilton College, he studied English literature with ambitions of becoming a writer. After graduation, he spent a miserable year attempting to write fiction, producing nothing of value and concluding he had nothing meaningful to say. Depressed and directionless, he discovered the work of Ivan Pavlov and John Watson on behavioral psychology. The idea that behavior could be scientifically studied, predicted, and controlled fascinated him. In 1928, he enrolled at Harvard to study psychology, finding his calling at age 24. Skinner's graduate work focused on animal behavior, specifically how organisms learn through consequences. He rejected introspective psychology's focus on thoughts and feelings, arguing that only observable behavior mattered. He developed the Skinner box, an experimental chamber where rats or pigeons pressed levers to receive food rewards. By carefully controlling rewards and punishments, Skinner could shape complex behaviors. He demonstrated that animals could learn elaborate sequences of actions through incremental reinforcement. His 1938 book, The Behavior of Organisms, established him as a leading behavioral psychologist. By 1943, Skinner was a prominent Harvard professor, known for rigorous experimental methods and radical views on learning and behavior. When World War II began, Skinner wanted to contribute to the war effort. His expertise was animal behavior, which seemed irrelevant to modern warfare. But Skinner saw connections others missed. The military's most pressing problem in 1943 was guided missiles. Germany was developing the V-1 and V-2 rockets, weapons that could strike from dozens of miles away with devastating effect. America was trying to develop guided bombs and missiles, but guidance systems were primitive. Radio-controlled bombs could be jammed. Mechanical systems were unreliable and inaccurate. Human pilots guiding bombs through wire connections or radio couldn't react fast enough. The military needed a guidance system that was fast, reliable, and resistant to countermeasures. Skinner realized that trained pigeons met all those requirements. Pigeons have extraordinary visual acuity and can be trained to recognize specific images. Skinner had demonstrated in his laboratory that pigeons could learn to peck at particular shapes or colors, ignoring distractions. Their reaction time was far faster than human reflexes. They worked without electricity, couldn't be jammed, and were immune to G-forces that would incapacitate human guidance. Most importantly, they were cheap and abundant. Training. A pigeon took weeks, cost almost nothing, and produced a guidance system more sophisticated than anything engineers could build. Skinner designed a system where a pigeon, harnessed in the nose cone of a missile, would peck at a screen showing the view ahead. The pigeon would be trained to peck at a specific target, a ship, a building, or a factory. Its pecks would be detected by a pneumatic or electrical system that would adjust the missile's control surfaces, steering it toward the target. As long as the pigeon kept the target centered by pecking at it, the missile would home in accurately. Skinner called his proposal Project Pigeon and submitted it to the National Defense Research Committee in 1943. The presentation was detailed and professional, with data from laboratory experiments demonstrating that pigeons could reliably track moving targets, maintain focus despite distractions, and respond quickly to target movement. Skinner had built a demonstration device showing pigeons successfully tracking simulated targets. He addressed obvious objections. Pigeons could withstand high G-forces. They operated in darkness using infrared or minimal lighting, and redundancy could be built in by using multiple pigeons voting on the target direction. The proposal was scientifically sound, carefully researched, and potentially revolutionary. The committee's reaction was skepticism, bordering on mockery. The fundamental problem wasn't technical, it was psychological. Military officials couldn't take seriously the idea of birds guiding weapons. It seemed preposterous, undignified, and vaguely insulting to American technological prowess. The United States was developing radar, proximity fuses, and early computers. The idea that pigeons might outperform electronic systems was intellectually offensive. Skinner's reputation as a serious scientist kept the proposal from being immediately rejected, but enthusiasm was minimal. The committee authorized a small budget for preliminary research, essentially telling Skinner to prove his concept wasn't completely insane. The grant was modest, barely enough to rent space and buy equipment. Skinner accepted and began work in earnest. He set up a laboratory in Minneapolis, recruiting graduate students and technicians. The team built training apparatus and began conditioning pigeons to peck at projected images. The training protocol was elegant. Pigeons were first taught to peck at a lit target for food rewards. Then the target was made smaller and moved randomly across a screen. Birds learned to track it, pecking rapidly to keep it centered. Then photographs of ships, tanks, and other military targets were projected, with birds trained to peck specifically at those images while ignoring background. The training was remarkably successful. Within a few weeks, pigeons could recognize specific target types, track them through distracting backgrounds, and maintain focus for extended periods. Skinner's team demonstrated that birds could track targets even when rotated, partially obscured, or shown from different angles. By 1944, Skinner had a working prototype. A pigeon, harnessed in a transparent nose cone, pecked at a ground glass screen showing the forward view. The pecking was detected by a pressure-sensitive surface, generating electrical signals that could control actuators. The system worked. In simulated tests, pigeons accurately guided model missiles toward photographed targets. Skinner invited military observers to demonstrations. They watched pigeons successfully track targets under various conditions, maintaining lock even with rapid maneuvers. The observers were impressed by the technical performance, but remained uncomfortable with the concept. One officer reportedly said, "It works, but we can't use birds. It's just too ridiculous." The military's reluctance was partly practical. How would frontline troops react to loading pigeons into missiles? Would enemy propaganda mock America for using animals because its technology was inadequate? What happened when pigeons inevitably failed, refused to perform, or became confused? Skinner addressed these concerns with characteristic thoroughness. Redundancy solved reliability, used 3 pigeons per missile with majority voting. Failures would be rare and no worse than mechanical failures common in existing systems. Propaganda was irrelevant if the weapons worked and saved American lives. But these rational arguments couldn't overcome the fundamental absurdity factor. The military had convinced itself that modern warfare required modern solutions, and pigeons were ancient technology, biblical even. Using them felt like regression, not innovation. Project Pigeon received continued but unenthusiastic funding through 1944. Skinner's team made steady progress, improving training protocols and demonstrating increasingly sophisticated targeting capabilities. Pigeons learned to distinguish between friendly and enemy vessels, to focus on specific parts of targets like bridges or gun emplacements, and to ignore decoys. The system's potential was becoming undeniable. Then, in late 1944, the military made a decision. Electronic guidance systems, though still primitive, were improving. Radar, television guidance, and radio control showed promise. These technologies aligned with America's self-image as a technological leader. The military chose to invest in electronics rather than biology. Project Pigeon was officially terminated in October 1944. Skinner was thanked for his efforts, his laboratory closed, and his pigeons retired. Skinner was disappointed but not surprised. He had recognized from the beginning that the project's greatest obstacle wasn't technical, but cultural. The military establishment couldn't accept that organic systems might outperform machines. Years later, Skinner reflected that Project Pigeon failed not because it didn't work, but because it worked too differently. Electronic guidance was understandable, a straightforward application of engineering principles. Pigeon guidance was mysterious, relying on processes no one fully understood. Military planners preferred systems they could comprehend and explain, even if those systems were less effective. The prejudice against biological solutions was so strong that even demonstrated success couldn't overcome it. The story might have ended there, a footnote in the history of military research, except that years later the Navy revived the idea. In 1948, with guided missile programs still struggling, the Office of Naval Research contacted Skinner about resuming pigeon guidance research under a new name, Project Orcon, for organic control. The Navy was desperate. Electronic guidance systems remained unreliable, expensive, and vulnerable to countermeasures. Radar-guided missiles could be jammed. Wire-guided missiles had limited range. Television-guided bombs required human operators vulnerable to fatigue and distraction. Skinner's pigeons offered a solution the Navy couldn't ignore forever. Work resumed with significantly more funding and military interest. Project Orcon ran from 1948 to 1953, producing remarkable results. Skinner's team, now with better resources, developed sophisticated training programs and guidance mechanisms. Pigeons were trained to recognize specific targets with near-perfect accuracy. Tests using pigeons to guide unpowered gliders showed they could accurately steer toward designated targets from thousands of feet altitude. The system was refined with better optics, more sensitive peck detectors, and improved restraints for the birds. Redundant triple pigeon systems were tested, with 3 birds independently guiding the same missile. Their inputs averaged for accuracy. The system worked beautifully. Pigeons successfully guided test vehicles in hundreds of runs with reliability exceeding contemporary electronic systems. Yet once again, the project was canceled. By 1953, electronic guidance had improved enough that military planners felt confident investing exclusively in technological solutions. Transistors were making electronics more reliable and compact. Infrared seekers showed promise for heat-seeking missiles. Early computer technology suggested that fully automated guidance might be possible. The military made a strategic decision to pursue electronic guidance exclusively, abandoning biological systems entirely. Project Orcon was terminated. Skinner's laboratory was closed for the second time. The pigeons were retired and the research classified. For decades, few people outside military research circles knew that pigeon-guided missiles had nearly been deployed. The irony of Project Pigeon's failure is that Skinner had invented the first practical fire-and-forget guidance system decades before electronics achieved the same capability. His pigeons provided autonomous guidance, requiring no external input once the missile was launched. They recognized targets without radio signals, operated independently of ground control, and couldn't be jammed or deceived by electronic countermeasures. These were exactly the capabilities the military desperately wanted. But the psychological barrier of using animals was insurmountable. The military preferred to wait for technology to catch up rather than deploy a system that seemed absurd, even if it worked. Modern precision-guided weapons operate on principles remarkably similar to what Skinner proposed. Optical guidance systems track targets visually, adjusting the weapon's trajectory to keep the target centered in the field of view. Infrared seekers follow heat signatures, maintaining lock through continuous feedback. These systems do electronically what Skinner's pigeons did organically, provide real-time target tracking and course correction. The fundamental concept, continuous visual feedback to guide a weapon toward its target, is identical. The only difference is whether the processing is done by neurons or transistors. In retrospect, Skinner was 40 years ahead of his time, proposing autonomous guidance when electronics couldn't yet achieve it. Skinner himself remained proud of Project Pigeon throughout his life. Despite its rejection, he wrote about it in his autobiography, describing it as one of his most creative applications of behavioral psychology. He never apologized for the absurdity of the concept, arguing that good science follows evidence regardless of where it leads. If trained animals provided better performance than machines, then animals should be used. The military's refusal to accept this reflected cultural prejudices, not rational analysis. Skinner believed that human civilization often rejected optimal solutions because they violated aesthetic sensibilities or challenged self-image. Project Pigeon was a perfect example, a superior system rejected because it didn't fit the narrative of technological progress. The classified nature of Project Pigeon and Orcon meant that for years most people knew nothing about them. When details finally became public in the 1970s and 1980s, reactions were mixed. Some found the projects amusing, evidence of wartime desperation producing bizarre ideas. Others recognized them as ahead of their time, organic computing before computers existed. Engineers studying early guidance systems realized that Skinner had solved problems they were only beginning to understand. The concept of using biological neural networks for real-time targeting was sophisticated, anticipating ideas that wouldn't fully develop until decades later with artificial neural networks and machine learning. Skinner's work on pigeon guidance also had unexpected scientific legacies. His research on animal training and behavior modification influenced fields far beyond military applications. The protocols he developed for rapidly training complex behaviors became foundational in animal training, education, and behavioral therapy. His insights into how organisms learn through reinforcement shaped modern understanding of learning and motivation. Project Pigeon failed as a weapon system, but succeeded as a demonstration of behavioral psychology's practical applications. Skinner showed that complex behaviors could be shaped systematically, that animals could be trained to perform sophisticated tasks reliably, and that biological systems could match or exceed mechanical ones in specific applications. The military's rejection of pigeon guidance also raises broader questions about innovation and institutional conservatism. How many potentially revolutionary ideas are dismissed because they seem absurd or don't fit prevailing paradigms? The history of technology is filled with concepts rejected by experts as impossible or impractical that later became standard. Submarines were called death traps, tanks were dismissed as vulnerable and slow, helicopters were considered engineering curiosities. In each case, institutional resistance delayed adoption until circumstances forced reconsideration. Project Pigeon fits this pattern, a working solution rejected because it violated expectations of what solutions should look like. Modern military research occasionally revisits biological systems, though usually at the microscopic level. Researchers have explored using genetically modified bacteria as sensors, insect-inspired robots for reconnaissance, and biomimetic materials for armor and camouflage. These projects face the same skepticism Skinner encountered, resistance to biological approaches in a technological domain. Yet nature often solves problems more elegantly than engineering can. Pigeon's visual processing remains superior to most computer vision systems in speed, flexibility, and efficiency. Their ability to recognize targets under varied conditions exceeds many artificial intelligence systems. Skinner's insight that biology might outperform technology remains valid even as technology advances. If Project Pigeon had been deployed in World War II, history might have changed significantly. American guided weapons could have achieved accuracy years before they actually did, potentially shortening the war. Ships might have been sunk, bridges destroyed, and bunkers eliminated with precision impossible with conventional bombing. The strategic implications would have been substantial, but this requires imagining a military establishment willing to embrace a solution that seemed ridiculous, and that willingness didn't exist. The psychological barrier was too great. American military culture valued technological sophistication and engineering prowess. Pigeon-guided missiles undermined that self-image, suggesting that nature might be smarter than engineers. That suggestion was unacceptable. Skinner died in 1990, having lived to see the electronic guidance systems he competed with become standard worldwide. Precision-guided munitions revolutionized warfare exactly as he had predicted, just using transistors instead of neurons. In his later years, he occasionally mentioned Project Pigeon in interviews, always with a mixture of pride and frustration. Pride because the system worked and demonstrated his theory's practical value. Frustration because military bureaucracy couldn't see past its own prejudices. When asked if he regretted spending years on a failed project, Skinner said no. The research was scientifically valuable, the engineering was sound, and the rejection taught him important lessons about human irrationality and institutional resistance to innovation. The pigeons themselves, the hundreds of birds trained for Projects Pigeon and Orcon, were eventually retired to aviaries or released. They lived out their lives unaware of their contribution to military history. No monuments were built to them, no medals awarded, yet they represented something significant. The intersection of biology and technology, the demonstration that organic systems could perform tasks reserved for machines, and the proof that unconventional solutions sometimes work better than conventional ones. They were living guidance systems, neural networks and feathers, computers before computers existed, and they were rejected because nobody could take seriously the idea that birds might help win a war. The legacy of Project Pigeon lives on in unexpected ways. Modern machine learning uses neural networks, computational systems inspired by biological brains. These systems learn to recognize patterns through training, exactly as Skinner's pigeons did. Computer vision algorithms that identify targets in drone footage use principles similar to those Skinner demonstrated: reinforcement learning, pattern recognition, and continuous feedback. The technology has changed, but the concepts haven't. What couldn't be achieved with pigeons in 1943 is now done with silicon. But the fundamental approach, training a system to recognize and track targets through repeated exposure and feedback, is identical. There's also a philosophical dimension to Project Pigeon's failure. It demonstrated that rationality and effectiveness don't always overcome cultural prejudice. The military had clear evidence that pigeon guidance worked, was reliable, and outperformed alternatives. Yet it chose less effective electronic systems because they felt more appropriate for modern warfare. This suggests that human decision-making, even in institutions supposedly governed by rational analysis, is heavily influenced by aesthetics, narrative, and self-image. We want our solutions to fit our story about who we are. America's story was about technological progress, not about birds. So birds were rejected, even when they were the better answer. If there's a hero in the story of Project Pigeon, it's not the military establishment that rejected it, or the engineers who eventually created electronic alternatives. It's B.F. Skinner himself, a psychologist who saw a problem nobody else could solve and proposed a solution nobody could accept. He didn't let absurdity deter him. He built working prototypes, trained hundreds of birds, demonstrated reliability, and provided a solution decades ahead of its time. That his solution was rejected says less about its merit than about the people evaluating it. Skinner understood something the military didn't. Innovation often looks ridiculous until it becomes standard. The airplane seemed absurd until it flew. The submarine seemed insane until it dove. And pigeon-guided missiles seemed laughable until electronics finally caught up to what birds could do naturally. Project Pigeon failed, but the idea succeeded. The concept of autonomous visual guidance, tracking targets through continuous feedback and course correction, is now fundamental to modern precision weapons. Every laser-guided bomb, every heat-seeking missile, every camera-equipped drone operates on principles Skinner demonstrated with pigeons in 1943. The implementation changed from organic to electronic, but the logic remained the same. In that sense, Skinner won. His vision became reality, just not in the form he proposed. The military got its autonomous guidance systems just 20 years late and $1 billion more expensive than pigeons would have been. The pigeons that almost won the war. They were trained, tested, and proven effective. They could have guided bombs with unprecedented accuracy, sunk ships from miles away, and destroyed targets conventional bombing couldn't touch. They represented the first practical fire and forget guidance system. Autonomous targeting before electronics made it possible, and they were rejected, laughed at, dismissed as absurd. Not because they didn't work, but because they were pigeons. The military couldn't accept that birds might be smarter than bombs, that nature might outperform engineering, that the best solution might come in feathers rather than circuits. So it waited, spending decades and fortunes developing electronic systems to do what pigeons could already do. Eventually, technology caught up, but Skinner's pigeons got there first, pecking at screens in laboratories, guiding missiles that would never be deployed, proving that sometimes the most revolutionary ideas are the ones that make people laugh, until they stop laughing and realize they should have listened.